Hi there. In this video, I want to take you through the concept of relation sheets in the AIMMS network design application, and more specifically in the data set. So the purpose of these sheets is really to create groupings of different things in your network, like your customers, locations, products, resources, and so on. And before I actually dive into it, there's two main purposes that you might want to create certain groupings. The first is to make your life easier once you're actually designing the input data set, as you can actually refer to the group names as opposed to the individual, let's say, product names, when the same data point applies to everything in a certain group, right? So if you think about a location, if you say, well, the transport cost coming out of every single East location group is the same, then rather than having to write down the 50 different East location names and writing down the individual costings, you can simply create a grouping called East locations and refer to that in the Excel template. So that's one key value. The second is, once you create these different groupings, you can combine them in the application itself, so network design, in order to run specific scenarios. So you could say, well, for this product group and this customer group, I want to change the demand in the application. And you can, bring those groupings to life in the app just by the way in which you have designed the relation sheets in your input template. So let's go through how you would set something like that up. It all starts in the configuration wizard, as always. So if you look at step 22, there are 5 options. Turning all of these on actually create specific sheets in your template, and they would be called resource relation, product relation, customer location, and period relation. So now let's actually transition over to the Excel template so we can see what these sheets look like. If I start from the product side, by the way, as I mentioned, these are all the relation sheets that you could see. In order for me to explain the product relation, we'll actually have to start from product definition. As you can see on the product side, you have the option or opportunity to really create or simply define initially the names of the different types of products you have in this data set. So you could have, individual products like monocrystalline, polycrystalline, thin film in this case, that we have marked as SKU. So it's just telling the application that these are the most detailed level of products that we have in the template. You could have a product grouping that we refer to as is union, that we have called solar panels here. And you could also have intersection, where you have a way of saying that, certain products either belong in one group or the other. So in fact, rather than explaining through this template, let me give you a very simple example. Assume that you have a product group that contains all blue shoes, and also a product group that contains all men shoes. So now if you create a product group that is union of these two groups, you will get all shoes that are either blue or men, right? So it would include every single possibility in those two groups. And that would be, you'd be able to call upon that in the data set. However, if you create a new product group that is intersection of those two groups, you will get all blue men's shoes. So it will be the specific shoes that are blue and they are men's shoes. So, with intersection, you can get products that are in both of the different subgroups. In most cases, people only use is union, but is intersection can be useful as well, especially when you have a much larger number of product groups. So coming back to this specific template, as you can see, we have certain SKUs and we have a certain product group. And there are some more here. But so far, we haven't really defined, or we haven't told the application what are the unique products that are part of this group and what are the unique products that are part of this group. So that actually happens in the relation sheet, right? So you could see that your products now are referred to as the sub-product because they actually belong in a larger group. And we have said that these 3 products are part of the solar panel group, whereas these 5 products are part of the raw materials group. And as I mentioned, anywhere in the template now, you can refer to solar panels, and the application would apply that data point to these 3 specific products. Now, in a similar vein, let's move forward to the different relation sheets. So location relation, in order for me to explain this, let's start with location data. So you can see in this template, we have a bunch of different locations. These are the actual physical dot on the map or the node that we have also geocoded. And these dots could, of course, be, your LDCs. It could be any resource, could be all of your different customers, finished goods suppliers, and so on. But you might want to create certain groupings out of them as well. So if you go into the relation sheet, one thing to again keep in mind is the terminology here. So although these locations are referred to as a location in location data, once we start grouping them in location relation, those are now the sub locations, right? Because they are part of a much larger group that we are creating. So how is that set up? It's very simple, as you can see. So you have all of your LDCs that we were seeing in location data, and we have said that these LDCs actually belong in one group that we call LDC. Now remember the 2 values. Not only can you refer to LDC later on in this template and create, let's see if we go to our transport cost data, we can see that we have referred to the LDC location group. And simply by doing that, and we also created a location group called CDC, simply by doing that, in one line, we have been able to say that there is a lane, every single lane between all CDCs and all LDCs is possible for the application to use. And of course, there is one cost per distance. So this cost is applied to every single lane. If you had a unique cost for every single lane, then of course this would not be the way for you to go. You would want to model them individually, but you could also have a combination of both. So some lanes could be grouped, some could be individual lanes. You have a lot of flexibility when it comes to that. So there's 2 more relation sheets in customer relation. So we took, all of our customers that we have defined. So Vienna, Linz, Graz, and so on. And we said, well, some of these customers are part of a retail group, and some of these customers are wholesale. And really, it's as simple as that. So once again, if you wanted, you could run a scenario where you say, well, in the application, you could say, I want to change the demand of all solar panels. So that includes the 3 unique products for all wholesale customers. And the application would be smart enough to recognize that and run a special what if scenario for you. You have the same idea once again. So on your your resource side. So of course we have a bunch of different production facilities, CDCs, LDCs in this data set. We can create a resource groups out of it as well, as we have here. And once again, if you needed to, in DC data or production data, you could refer to those resources if they had, refer to those groups if they had the same value assigned to it. In this template, it's interesting. So we are not using the groups because a lot of these, resources have a unique capacity or a different capacity attached to it. So we don't want to just create one group because then that would assign the same capacity to everything. So this was a quick rundown of this functionality in the application and how you can create groupings by leveraging the relation sheets. If you have any questions about this, or if you want further insight, feel free to just leave a comment at the bottom or reach out to us at our support desk. Thank you.